All right, so let's put this whole confidence interval thing together. Suppose I want to know what the average IQ of Jeffco students is. I survey 10 students. I find the average for that sample is 102, and the standard deviation for that sample is 10. And I want a 95% confidence interval. So I want to be 95% sure that I actually have captured the average IQ of Jefferson College students within that interval. We can do this with our calculator. You already know how to do this. The mechanics are exactly the same as we've been doing in the last couple quote unquote lectures. But let me show you how to do this in the calculator. I'm going to zoom in a little bit. Picture of the screen is not very good. Okay, we're going to go to Stat and then arrow over to Tests. And we're going to be spending most of the rest of the semester with some of these different tests here. The one we want at the moment is number 7, Z interval. Remember, one of the numbers that we used, our 1.64, 1.96, or 2.58, was a Z score. And that's why we're using Z interval. We hit enter, and we have a menu of things to fill out. And I apologize, my screen's starting to go bad, so it's getting a little tough to read. We want to have stats highlighted. Data is a different thing. We're not going to do that this semester. Go to stats. The first thing it asks us for is sigma. That is our standard deviation. So we tell it 10. X bar, that's our mean for our sample. That's 102. Our n is the size of our sample, as always. So that's 10 in this particular case. And our confidence level is 0.95. That's already in there. We can change it, though, to 0.9 or 0.99. Calculate, and it gives us our interval from 95.802 to 108.2. So we are 95% sure that the average IQ for Jefferson College students is between 95.8 and 108.2. In other words, if we repeat this process 100 times, about 95 of those times we would actually create an interval that contains the mean of the population itself. That's what we mean by 95% confident. If we would do this over and over again, about 95% of the time we'd be right. So let's look at the next one here. We survey 100 Jefferson College students and find that the average commute time for that sample is 24 minutes with a standard deviation of 8, and we want a 90% confidence interval for the actual average commute time for the population of Jefferson College students. We go to Stat, over to Test, down to Z interval, enter. And we put in our information. Our sigma this time, standard deviation is 8. Our X bar was 24, average 24-minute commute for the students. 100 students in the survey, and we want a 90% confidence level, so 0.9 there, and then calculate. And we get an interval from 22.7 to 25.3. So we're 90% sure that the actual average commute time for Jefferson College students is between 22.7 and 25.3 minutes. Now, notice this is a much narrower interval. The interval that we got for the previous example, sorry, you can't see it on the screen anymore. The previous we got for the interval that we got for the IQs was a much wider interval. It was from like 95 to 107 or something like that. And this one's from 22 to 25. That's for a couple reasons. We had a smaller standard deviation in this example, and we had a much larger sample. We'll talk about this in a future lecture, but the bigger the sample, the more narrow our margin is going to be. Now let me give you a couple. If we measure 100 pine trees, and the sample average is 80 feet. So the average of the sample of trees is 80 feet tall with a standard deviation of 10. Find a 95% confidence interval for the heights of the trees. Go ahead, pause it, put the numbers in your calculator. Again, that was 100 pine trees. The average height's 80 and the standard deviation's 10. and we want a 95% interval. You should get 78.04 to 81.96. As always, if you did, good. If not, go back and figure out what you're doing wrong. A second one. We go to Subway and we measure 25 foot-long subs. Our average length for the sample is 11.9 inches. The standard deviation is 0.15 inches. We want a 99% confidence interval. Again, that's 25 foot-long subs. The average length of those subs is 11.9. The standard deviation is 0.15. We want 99% confidence. You'll get between 11.823 and 11.977. Now that's very narrow, 11.8 to 11.9, but that's because the standard deviation was very small, it was only 0.15. All right, hope that all makes sense. Talk to you again soon.